Okay, hi everyone, welcome back to this video series, Introduction to Firewalls. Transport layer protocols. Most IP packets contain data that is specific to a transport layer protocol. A transport layer protocol defines additional information in the packet. For example, whereas the IP protocol is responsible for getting packets to another computer, a transport layer protocol may contain sequence information that is used to assemble multiple packets back into the right order. The Internet Assigned Numbers Authority, IANA, maintains a list of these transport layer protocols at http www.ina.org. Assignments protocol numbers. This list currently contains 134 protocols, but most of the time you have to be concerned only with a few of them. The appendix of this book also contains a list of the most frequently used protocols. Because the vast majority of the traffic on the internet uses either the TCP or the UDP protocol, UDP and TCP, the main difference between UDP, User Datagram Protocol, and TCP, Transmission Control Protocol, is that UDP is connectionless, whereas TCP is connection orientated. What does this mean? A connectionless protocol doesn't make sure that all packets that are sent are also received. UDP is like an answering machine recording. When you reach an answering machine, the recording starts playing. The answering machine makes no attempt to confirm that you are indeed listening or that you understood the message. After you leave a message on the answering machine, you can't confirm that the answering machine did indeed receive your message or that it received it in its entirety. You just have to trust the machine. Similarly, a computer sends UDP packets, but the UDP protocol has no provisions for checking whether all packets arrive at the destination. Because of this, UDP is sometimes referred to as an unreliable protocol. TCP is similar to a telephone conversation that you have with someone. Before you start talking, you establish that each participant in the conversation can hear the other one. You also ensure that the other participant in the conversation can understand you. If one person doesn't hear part of the conversation, he will ask the other person to repeat the part that was lost. Like a telephone conversation, TCP has provisions for session setup and session maintenance. Both hosts that are part of a TCP connection keep track of the conversation. The first step is a three-way handshake, a succession of three network packets that are used for session setup. During this three-way handshake, both hosts agree on a number of communication parameters, such as how to number all of the packets so they can make sure that the packets can be reassembled in the correct order. Also, if packets get lost in transit, one host can inform the other about this and request retransmission. Because TCP keeps track of the transmission and ensures that all parts of the transmission are successful, TCP is sometimes called a reliable protocol. When is UDP used and when is TCP used? UDP is sufficient for many types of network traffic. For example, when you're listening to a live radio program over the internet, UDP is the perfect protocol. Suppose that one of 10 packets from the internet radio station gets lost because of some severe congestion on the internet. Because every 10th packet is lost, you will hear short breaks in the radio program. However, the listening experience will be even more disrupted if the missing pieces would have to be retransmitted. Nothing would come out of the loudspeaker until each missing packet had been received. Maybe 5 or 10 seconds after they were intended to be heard. TCP, on the other hand, is more appropriate for network traffic that requires the integrity of the information that is sent. For example, if you're downloading a file from the internet, your main concern is that the file arrives intact. If portions of the file don't make it, you want to take advantage of TCP's ability to automatically retransmit packets that were lost in transit and to assemble all packets in the right order ports. When dealing with TCP or UDP packets, you often hear the term port. No, this doesn't mean that these protocols are designed for mariners. Instead, a port is the number that identifies where a packet came from on the sending host and where it should go to on the receiving host. If you compare an IP address to a street address for mail delivery, the port number is like an apartment number. When a server application such as a web server runs on a computer that uses TCP IP, it reserves a port on that computer. This reservation is nothing more than telling the networking software that any packet that is addressed to this port should be forwarded to the server application. Any application that sends TCP or UDP packets also send them from a port. This way, the TCP IP stack knows what application should receive return packets. In addition to source and destination addresses, IP packets also contain source and destination ports. Many server applications use standard ports so that client applications know what port on the target host to address a packet to without querying the target host first. For example, most web servers respond to client requests that are addressed to TCP port 80. Numbers can be re-registered, and most server applications use the port that has been registered for this type of application. Ports under 1024 are the most exclusive ports and are known as well-known ports. You can view a list of well-known ports and other registered ports that the Internet Assigned Numbers Authority maintains at www.ina.org/assignments/port numbers. Each application running on a computer has to have its own port so that incoming packets can be sent to the correct application. Web requests should end up with your web server application. Email should end up with your email server application, and so on. Consider the following example. A client computer running a web server tries to connect to a web server. As the web browser requests a connection, the TCP IP stack springs to action and sends a packet to the web server. This packet is addressed to port 80 at the destination, the standard for web servers on the web server. The client's TCP IP stack also includes a source port number. For client requests, this is normally an unused port number between 1024 and 65535. This number is used as part of the address when the web server returns the packets to the client. In our example, the client picks port 1028. The resulting packets are sent to and from the web server as shown in table 2.3. The inclusion of the port number allows both sides to keep track of which application needs to process incoming packets. Because each conversation uses a unique set of port numbers, multiple programs on both computers can communicate with each other simultaneously. So here we have table 2.3, properties of TCP traffic in sample connection. So to web server TCP, source IP 172.16.1.200, source port 1028, target IP 172.16.1.1 target port 80 to client TCP 172.161.1 port source port 80 target IP 172.161.200 target port 1028 application layer protocols. So I'll move that down. You may think that we spent a lot of time in this chapter talking about how to get network traffic to the right destination and getting it there intact. However, we haven't talked about what is contained in this IP traffic. This is what application layer protocols define. Some of these protocols define how files are transferred, and some of them deal with email messages, but each of them defines how data is passed from one program or application to another. After you strip the IP and UDP or TCP information from an IP packet, what remains is the information that is passed to the application layer protocol, and that tells the program using this protocol how to perform a specific action, such as transferring data. HTTP. As protocols go, HTTP Hypertext Transfer Protocol is a relative newcomer, but for most internet users, it's the protocol that matters the most. Web clients request this protocol to request web pages and other web objects, such as graphics that appear on web pages from a web server. By default, web servers listen on TCP port 80 for requests from clients, but you can also configure a web server to listen on a non-standard port. If you do this, the clients need to specify this port when connecting. When you use a web browser to connect to a web server on the internet, you normally use a URL, Uniform Resource Locator. A URL contains the following components: protocol, address, port, content. The protocol can be one of several protocols that the web client understands, but most often it is HTTP. The address is either the IP address of the server that you want to connect to, or the DNS name for which your computer finds the corresponding IP address. The colon and the port are optional, and you only have to use them if you're using a non-standard protocol. For example, if you use HTTP and the protocol as the protocol and don't specify a port, your web browser will connect to port 80 on the server, because this is the default port for web requests. Finally, the content may be a specific file on the server. For example, if you're requesting a web page and you don't specify a specific object, the web server will normally send its homepage to the client browser. SMTP. SMTP is the Simple Mail Transfer Protocol. SMTP is used to send email messages to an SMTP server. Some packets to SMTP servers come from client computers, but you can also configure multiple mail servers to send email to each other for further delivery. The SMTP protocol uses TCP port 25 on the server. POP3 Post Office Protocol version 3 is another email protocol, whereas SMTP is used for sending email. POP3 is a protocol that your mail program uses to retrieve mail messages from your mail server. Clients connect to the server on TCP port 110. DNS. The DNS, the Domain Name System Protocol, is used to convert DNS names to IP addresses. Normally, client computers need to convert a DNS name to an IP address quite often. To do this conversion, a client computer may send a request to a DNS server, which by default allows connections on UDP port 53. This DNS server may then have to contact other DNS servers to help with the name resolution request. These servers also listen on UDP port 53. If a DNS transaction involves more data than what fits into a UDP packet, DNS may automatically switch to using TCP port 53 instead. Also, DNS servers may transfer data between each other that consists of entire DNS zones using a process called zone transfers. Also use TCP port 53. Telnet. Telnet is an application that allows you to remotely connect from a Telnet client to a Telnet server and get a remote terminal session, such as a command prompt window on the server. A Telnet server listens for incoming connections on TCP port 53. All communications between a Telnet client and a Telnet server use this port on the server. Windows includes a Telnet program that you can use to establish a Telnet session. However, using the Telnet program to connect a non-standard port can also be a great troubleshooting and firewall testing tool. You can specify any port on the command line to see whether you receive a reply on the port that you specify. For example, to see whether the web server for www.dummies.com responds, type the following command inside a prompt window, and when connected, press enter a few times to see the response from the web server telnet www.dummies.com 80. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.